Good morning everyone, welcome to the homework portal questions. This is question number 3 which will be published on 25th of September as shown over here. Okay, this question is for 9 marks and so I have made it equal to 9 minutes over here. Let me solve it in 9 minutes. Okay, so a wooden block of mass for weight 4 Newton. When you say weight 4 Newton, the mass should be equal to 4 Newton divided by 10, which should be equal to how much? 0.4 kg. Rest on an inclined plane as shown in the diagram below. The plane is tilted with an angle theta equal to 30 degrees is reached. The block is just about to slip. When you say just about to slip, which means what? The upward force equal to downward force, which means, so when you have frictional force, see it is about to slip, frictional force will be acting like this over here, and your what you call mg sin theta will be acting one more component of mg will be acting like this here. Okay, the question is draw and label the forces acting on the block. So what are the forces acting on the block? This was 3 marks. Okay, so therefore now what we do is let us put normal force here, then mg force over here. Okay, see you have to draw, you have to label also, and then let me draw a line parallel to this like this over here. Okay, along the line. So therefore if this is theta, this is 90, this should be 60 and this should be 30, right? Because it's perpendicular here. If you want, I can make a much more clearer diagram. So it is like this. So this is your incline, this is your incline, so which is nothing but theta equal to 30 degrees over here. If this is 30 and this is the place where you have kept the object over here. Now with respect to this object, I will draw from the center of the mass of this object, I will draw a perpendicular here. So if this is 30, this should be 60 over here. Okay, since this is 90. Now normal force is acting like this over here. And then if I draw a line opposite to the normal force like this over here. Now what will happen if this is 60, since this is perpendicular, this angle should be 30 degree over here. Okay, and now since this is your mg force, see this is your mg force, component of mg along this direction should be mg cos 30. What is mg cos 30? So you can write this as mg into root 3 divided by 2. And along this direction, this should be mg cos 60, right? Which should now be equal to mg divided by 2. I will write down here mg by 2 here, frictional force here, and this is mg into root 3 by 2. I have written all the forces now. Now, next, show that the coefficient of friction between the block and the plane is 0.60. So what should I do? See, when it is about to slip, which means that this mg by 2, this downward force is equal to upward force, should be equal to frictional force. So when I do this, now what will this be? Frictional force is nothing but mu times n. And what is n here? N is nothing but equal to mg root 3 by 2. See, this n is equal to mg root 3 by 2. So I can now substitute that. I can write this as mu times mg into root 3 by 2. Okay. So therefore this mg and this mg goes away. This 2 and this 2 goes away. So what I am left out with? I am left out with here on the left hand side I get 1 here, and here I get mu times root 3 here, which means I can write mu is equal to 1 by root 3. Let us find out what is the value of 1 by root 3 using a calculator. So 1 divided by root 3 value is 1.732. 1.732. If I substitute this value, I get the answer as 0.577. 0.577, which is closer to 0.6 because 60, which is two significant figures. I can write like this. Okay, next. The block is now held on the plane while theta is increased to 60 degrees. Now what is happening? The angle of the incline is made 60 degree. Now it is made like this. It's made like this. Okay. So when it is made like that, it is then released. The object is then released. Calculate the initial acceleration of the plane down the plane. Initial acceleration of the block down the plane. So as a result of it, the block that is kept over here will now start sliding like this. Now what is the acceleration of the plane? That's the question. So when you have like this, let us draw the plane once again here. So this is the plane, this is your angle, and the object is kept over here, and this is my normal force. Now this comes like this way, right? Mg sin theta. Now what's happening is that when I lift this plane, the angle theta is larger. So that means mg sin theta becomes larger as compared to the frictional force. Thus, this force is larger, this as compared to this one. Thus, the net force will now be equal to mg sin theta minus frictional force is equal to m into a. Right? That's what I get. Now, what is FF? frictional force, have you calculated frictional force? No. Okay, so we know that this can be written as a mg sine 60 minus, what is frictional force? Mu times mg cos 60. Why mg cos 60? Mg cos 60 reason is because this normal force is equal to mg cos 60 over here, right? Cos theta. N is equal to mg cos theta. So I applied mu times n is equal to m into. Now what we're doing? Okay, we are cancelling this. So we have m cancelled on all the sides. Now let me expand this. This should be g sine 60. What is sine 60? Root 3 by 2 minus g. What is mu? Mu value we found out somewhere here. No, what is the value of mu? Mu is 0.60. Okay, so let us substitute this 0.60 multiplied by 0.60 multiplied by g multiplied cos 60. Cos 60 is half, should be equal to a. Let us find out what is this value here. So this should be g into root 3 minus 0.6 into 1, which is 0.6 divided by 2 is equal to a. Let us use our calculator to find out what is the answer here. Where is it? Where is my calculator here? It's here. Okay. So this should be 1.73 minus 0.6 is equal to 1.13 divided by 2 is equal to so much multiplied by 10, which should be 5.65. So thus the value of A is equal to 5.65 meter per second square. Let us see the marking scheme. It says 5.7 meter per second square, 5.7 meter per second square. Okay, which is corresponding to two significant figures, right? So I think with this we come to an end to this problem. Okay, let us see tomorrow's problem into detail about the circular motion. Thank you.